Okay, so here we look at table representation of a function. So the idea is, once again, as I mentioned earlier, now sometimes, as the way how I explained in class, a function is just somehow a rule. Say you have a set x and you have a set y, and the function is just a way, somehow a rule to take one input, one particular member from the set x, and map that to a member in the set y. And you don't have to know, I mean, for now we don't have to be concerned how it maps to 1 to 6, but all we know is it's somehow a rule that it maps a member from x to a member in y. And so now this kind of diagram here is confusing to you sometimes. So an alternative way to represent a function is using a table. So the idea now is that you can see that all the members on the x set right here, you can lay it down. You can lay it down on a table with two columns. One column is the vertical. One column is for the different inputs value, different values from different items from the set x, and the other column here is what represents the function's value. And so, once again, quickly, you can have -2, -1, 0, 1, 2, and maybe 3. Okay, so here you can go somehow. Once again, I don't have to know how, but my function map take 1 to 6, take 2 to 7, take 3 to 8, take -2 to 4, take -1 to 3, and take 0 to 2. Just something like that. So the idea now is that here is a function, a representation of a function as a table. We have two columns. The column on the left hand side here is all the x value, is all the different x value that the function can take. And then correspondingly on the right hand side here, on each column, on each row right here on the right hand side column, it's indicating a function that, say, the function f is taking -2 to 4, taking -1 to 3, taking 0 to 2. And so that's a function, a table representation of a function. So now in this particular example, the kind of questions, a lot of time when you have a table representation of a function like this, the type of question we're going to be concerned about is, say, how about question part A? What is the domain of the function? When you're just seeing a function represent as a table like this, what is the domain? And let me remind you again, the domain is just simply all the x values on the table, all the x value from the set x, all the values from the set x. So here my domain would be just simply -2, -1, 0, 1, 2, and 3. Those are all the values from the set x. Those are all the elements from the set x. That's your domain of the function. And the range would be the corresponding the values on the right hand side column. So here the range of this function would be, and a lot of time we would write those in order. So it's gonna be 2, 3, 4, 6, 7, and 8. You don't have to worry about writing these values here correspondingly, but the idea is I'm trying to keep them in order. Okay, so that's the answer of domain. So once again, the recap here is domain from a table representations. The domain is simply all the x value, all the values that you can pick from the x column. The range would be all the values that you can pick up from the right hand side column, the f of x column. So now the next type of questions regarding to this table here. So now once you have a table, someone can be asking you, what is the function's value at -1, for example? So remember, this notation is telling me that my function is f. It takes x equals -1. So when x equals 1, what is the function value? What would the function equals to? So now, to answer that question of yours, the only mean we can rely on this time is the table. So now when x equals -1, as indicated here, as indicated x equals -1. So when x equals -1, correspondingly the function's value equals 3. That's indicated on the right hand side right here. So the table here is, you can think of that just like a chart here indicating the correspondence between an x value and a function value. So now my f of -1 equals 3 in this problem. And then if I'm asking, how about f of 0? What is the function's value at x equals 0? At x equals 0. So once again, you can just look it back, and it's right there. Once again, on the x column, x equals 0. Correspondingly, f of x equals 2. I'm sorry. So here, that's the answer. Now, there is a limitation on the table like this. What happens if someone is asking f of 5 equals 2? Okay, so now that means in this case x is going to be equal to 5. You're going to look into your table on the x column. Do I see 5? Can I locate 5 anywhere? I cannot see 5 anywhere. So in here, my answer is an unknown. Okay, I don't know this answer. So, and I mean, no one's going to be asking you some question like this when they give you a table with a limited number of inputs like that. Okay, and now once again, directly from the same idea of a table, what happens if someone is asking you a question such as a question in part C, such as find x. We want to find the x value such that f of x equals 4. Okay, so meanings, we want to go back on the table. We want to go back on the table and find out. I want my function value to be 4 this time. I want to find out which x value gives me 4 for the function value. So it means on the right column right here, 4 is the function value. So what x value is that? -2. So now that my answer here is, that means the answer x equals -2. Okay. So similarly, you can ask us questions again, the same question. We can try find x such that the function's value at x equals 8. Okay, and so now look up on your chart. 8 is the value of the function. That means you can find 8. You can find 8 on the right hand side column. So here on the right hand side column, where can I find 8? 8 is here. 8 is here. So what x value give me f of x equals 8? Which x value corresponding to 8? X equals 3. So now my answer to the questions, x equals +3. And that's how, that's a few things you can do with a table representation of a function.